Hello guys, welcome back to the channel for another Databricks video. Today we are going to continue with Databricks Delta Live Tables, slowly changing dimension and CDC, capture data change. But this time we are going to add an Azure SQL database in the mix. In the Databricks Academy they have many examples where they generate fictitious CDC data. Now this is all well and good when it comes to making a demo, but is it the same in real life? No. And that's why this time I used an Azure SQL database. I enabled CDC and I used Delta Live Tables and applied changes to process the CDC data feed in Databricks. I wanted to demonstrate something that could be used at work. Okay, let's get down to the nitty-gritty and move to our Databricks workspace. Okay guys, before we move into Databricks workspace, first we need to create a table and enable CDC on this table in our Azure SQL database. Normally at work we will have a database with many tables, so let's create a new one called test123. We will have ID as a primary key, would be integer, email address, first name, last name, gender, t_order, that would be a timestamp column. Now if it's an append only table, using this timestamp column or this date column, we can actually get the delta changes, so based on the timestamp, right? But we want in our case to propagate the updates and the deletions, which is pretty important. That's why we have CDC. So let's enable CDC on our database using this command sys.sp_cdc_enable_db, and then this command to enable CDC on table level, specifying our schema, source name of the table, role name, supports net changes equals to 1. Now you can find all these commands here in the Azure documentation and here as well, so it's pretty easy, just Google it. And then let's insert some values, right? So let's insert this one, and then this one, and this one, and let's insert the rest of the two in one go. And we have 5 records, right? So at least 5, yeah, 5 records. As you can see on the 5th record, we have null as first name and null as last name. Now let's delete the first record with ID 1, right? So select delete from this table where ID equals 1, and then update record number 2 with last name, this one, test 1 2 3 4 5. Let's do that as well, and let's update the same record with the same ID again, and again the last name. And you will see why we are doing that. So run this command, and then if we select from this table and see the results, we will have 4 columns. ID 1 of course has been deleted. ID 2 now has the latest last name that we updated, and this record, as we mentioned, there is no first name and there is no last name here, right? So we have 4 records in our table now. Let's go back, and here if you refresh, you will see those CDC DBO_test123_CT table, and you will see this table has our data, the data we want. We have start LSN and SQL val, operation, update mask, ID, and the data, actually all the columns here, command ID. Now one thing aside from the data here, ID, email, first name, last name, right? As you can see, we have more records, and the reason is we keep track of the history, right? So Apo, this record with record number 1 was deleted, and now if you can see, this is the operation. Now under the operation column, we specify when we enable CDC, we know if it's an insertion or update or a deletion, and you will see that here in the documentation as well. If it's 1, then it's delete. If it's 2, it's insert. If it's 3, it's update before image. If it's 4, it's update after image. So we have the value in case of the update, we have value before we updated the record, and after we updated the record. That's why we have more records here. And as you can see, the last operations, when we updated this record, number 2, we have operation number 3, operation 4, number 3, and number 4 again, because we updated the same record twice, right? Okay, so we have this data here. This is amazing. And one more column. Now you see, this is that's the tricky part when it comes at least to Azure SQL database. When we need a column with the timestamp that, you know, this operation took place, this action took place. So when we delete the record, we want that timestamp that this transaction happened. So we can find this data here in the CDC LSN _ time _ mapping, and you will see, let's run this command, you will see we have for start LSN that we have it here as well, but with underscore, and we have this column here as well, and then we have the begin time, end time, transaction ID, etc., etc. So in our case, we are going to use the transaction begin time. You can use the transaction end time as well. And we are going to use this column here in our, when we apply slowly changing dimension type 2 in our Databricks workspace using Delta Live tables. Let's see what we have here. So in this notebook, we are going first to create a Delta Live table called lookup _ time _ table, and we are going to get the data from the cdc.lsn _ time _ mapping, which is this data right here that we just queried, and you will find it in your database. So we want all the data from this table. Actually, we want 3 columns. I just select 3 columns, but this is how you can create a Delta Live table using this return statement, spark.read. We specify the format, SQL Server, the table name, the host, port, database, user, password, etc. .load, and then we select the columns we want. I loaded only start LSN, transaction begin time, transaction end time. And then one second table on the bronze layer again, because that could be the bronze layer. We will have this table on the bronze layer and this table as well on the bronze layer, called users _ CDC _ bronze. And these we are going to connect to the database, and we are going to select the data that we selected from this table. Now this table, remember, it has start _ LSN operation, and also the actual data, ID, email, first name, last name, gender, T order, right? So we want the actual data plus the operation column, because we want to know if it's an insertion or update or a deletion, and the start LSN, because we are going to join this table and this table, because actually we want the transaction begin time timestamp column. You will see. So both those tables, will load them using Delta Live tables on the bronze layer, and we just rename those 2 columns because, as you can see, they start with __, and when you select, then it's not going to work, unfortunately, because it has __. So we just rename the operation column to operation and start LSN to start LSN without the underscores and the $sign, of course. So that will be the bronze layer. We just dump the data from the database as it is in the database. So then we have the clean layer or the serial layer. It doesn't really matter how you say that, but we have the clean layer here that we apply data quality rules. Remember, on the serial layer we apply data quality rules. We quarantine corrupt data, the data we don't want go to another table, and we, in general, again, we apply data quality rules, and we can do that by using this dictionary, specifying the rules we want. First name shouldn't be null, last name shouldn't be null. Again, we create a Delta Live table called users _ CDC _ clean, and we apply data quality constraints using this rules here. Now we named the dictionary drop underscore rules, and we pass the dictionary here where we use the Python decorator dlt.expect all drop rules. So if there is invalid record, it never reaches the target table in this case. And we have expect or fail if the ID is the ID has to be greater than 0. Otherwise the pipeline will fail. And here we have one table, use the user's CDC bronze, right? And one table, the lookup table, so this table and this table. We load those tables using dlt.readStream, and inside the return statement we performing a join. Remember, we said we are going to join those tables because we want the transaction begin time. So clean_1, which is the main table from the CDC underscore bronze, and we join with the lookup table. Inner join in this case, pretty straightforward, based on start LSN, which is a unique identifier. So here, as you can see, that's a unique identifier. So we join based on this start underscore LSN column, and because we want the transaction begin time. And then we have the quarantine rules, which is where the invalid records go actually. And the quarantine rules are exactly the same as the drop rules that we applied in our clean table, but we just we reversed the rules by using not. So everything that the first name, if the first name is null and the last name is null, then goes to this table called users underscore CDC underscore quarantine table. And here we just read from the bronze layer. Pretty simple, we just quarantine the data we don't want. And this is amazing because you do that with only one Python decorator. Pretty amazing, I would say. And here is where we apply slowly changing dimension of type 1 and type 2 using delta live tables. First, we need to create the target table, and it has to be a streaming table. That's why we use dlt.create streaming live table called slowly changing dimension type 1 underscore users. That will be the target table. So in dlt.apply changes, we specify the target table, the source table, that would be the clean layer that we created up here after we cleanse the data from the corrupt records. And we specify the keys, that would be ID in our case, sequenced by the transaction begin time. Remember, this is why we want this. And operation equals to 1 when it comes to deletes. So deletions means operation equals to 1. And we accept those columns because we don't actually need them, and we store our slowly changing dimension type is of type 1. We are doing the same using slowly changing dimension of type 2, right? So we can keep track of the history of the records. So we create a new streaming live table called slowly changing dimension type 2 underscore users, same source, keys, sequenced by the same timestamp column, apply as deletes operation equals to 1, except column, again we don't need those columns, doesn't really matter. Actually, let's leave that, and let's see what we get. So let's actually, this is it. Yeah, I think we are good to go. Yeah, I think we are good to create a delta live table pipeline here. Let's create a new one, demo path. Let's specify our notebook here, target demo, target schema demo, that's fine, fixed 0 workers because, well, we don't need anything expensive right now. And let's start the pipeline. It will take a few minutes because it has we have to wait for the resources to gather the resources and then initialize and set up the tables, so give it a few minutes. As you can see now, the data is flowing between the layers. Now on the bronze layer, you can see here we have the materialized views, right? So users, CDC bronze, and the lookup table. And then here on the string table, we actually join those two tables. You can see the arrows here, the moving arrows. This step is still running. The quarantine table has been loaded with one record. Remember, there's one record without first name and last name, so this is what goes here. And then using slowly changing dimension of type 1 and type 2, we expect to see the results of those operations here. Let's see, 3 records for slowly changing dimension of type 1 and 6 records for slowly changing dimension of type 2. Now the cool thing about here you can see, you can see the data quality, the schema, the flows, right? But in the data quality here, as you can see, valid first name, one failed, we have one failed record, right? And that one failed record went actually here. So because 9 failed records here, because these 9 records are valid, but one was correct, one was indeed corrupt, and it went to this table. And let's see what we have on all those tables here, right? So let me spin up my interactive cluster here, and let's see what we have in our Hive metastore. Okay guys, so here we are under the demo schema. We have all those tables. Let's check the bronze table, which is the one that we load the data as they come in. We don't make any changes, we just dump the data. We replicate actually the table from the database, except that we rename this operation column, so we have all the data. This is exactly what you will see in the database. Then we have the lookup table with start LSN, transaction begin time, transaction end time. So we need to load this data as well in order to get those two columns. And then we have the clean table, which has the clean data. So we don't have any corrupt data. Here we have 9 records. The 10th record actually went to the quarantine table, which is the corrupt record because it doesn't have first name or last name. So let's let it run. Yeah, as you can see here, it doesn't have first name or last name. That's why it went to the quarantine table with all the invalid records. So now we apply slowly changing dimension of type 1 here, which has the latest version of the data. You can find the same data on the original table. So we have here, let it run. We have 4 records. Here we have 4 because actually we haven't filtered out the invalid record. So essentially we have 3 records. Those 3 records can be also viewed here in the slowly changing dimension of type 1. We have the latest version of the data, but if you want also historical data, that's why you apply slowly changing dimension of type 2. Now as you can see, right, ID 1, that is the record that we deleted, and that's why it has a start at time and end at time. So you know that this record is closed. That's why it has an end at timestamp. So it was closed at this timestamp. Then we have record with ID number 2. As you can see, we have actually 3 records, and this is why this is because first we had the original data, John Test, as last name, and this record was valid for this between those 2 timestamps, and then we changed the last name to test 1 2 3 4 5, and this was valid between those 2 timestamps, but the latest version with this last name, new update surname, is still valid. That's why the end date is null. So if the end date is null, that means this record is valid. This is the latest version of the record. So now you can filter based on the time range you want and all those things, what the business analysts want. So this is essentially how you can use Delta Live tables to create all those awesome pipelines, data pipelines. As you can see, it's pretty amazing that you can see the data flowing in real time, and you can see, you know, which records were valid, which records were dropped, and all this kind of things, and the number of records written. So it's pretty amazing. I really like Delta Live tables. Although they are expensive, they are quite fancy and useful. This is it for today, guys. I hope you found this tutorial useful and insightful. I got it something, you know, practical. I think it's important to know how to apply slowly changing dimension and CDC in real life scenarios using Delta Live tables, because, you know, in the end, we cannot only depend on simple examples. Hope you enjoyed the video. Please click the like button, subscribe to the channel, leave a comment, and I will see you in the next one. Thank you.